So if you've played the activity or not, what we should see is that if we choose a bunch of x values here, I'm going to look at the table on the left hand side and say x. I'm going to start with 0. I'll go up with 1, a 2, a 3, a 4, a 5. And we consider the idea of x squared. And we set that equal to y. Okay, we want to know what the squared is. Well, what's 0 squared? 0 times 0. 0. And if I was to put that coordinate here, x, then y, on a Cartesian plane over here, let me just make it red. Okay, that would be at the location here, 0, 0. Now what's 1 squared is 1. So that when I choose an x value of 1 on the number line, this way, it's going to go up to a height of 1. And so the next point of that graph would look like this. Okay. Next would be 2 squared. 2 times 2, 4. So when I choose an x value of 2, it's going to have a height of about 4. This is not perfectly to scale. 4. Now notice the height keeps going up and a little bit faster this time. The next number is going to be 3 squared. 3 times 3 is 9. So my next number over at 3 is going to have a vertical height all the way up to, well, I'm off my scale, but I'd say that would be about here. 9. A height of 9. I'll just put that up there. And what we've already seen from your activity is that if you were to connect the dots, because you could have you could have values in between. Let me just ignore these guys right now, 4 and 5, because that's way off my scale. But if you were to also to plot values of 0.5, you'd even get them in here as well. And in the end, you would get a curve that looks like this. So this is essentially the basics of a y equals x squared curve, known as the quadratic. Now, what's important is that we can also go back to our table and choose x values that go this way, into the negatives. So, again, if you pick -1, well, that's going to be -1 times -1, which is +1. And therefore, the graph starts to go back up. When you pick -2, well, that's going to be -2 times -2. Negative times negative is positive. 2 times 2 is 4. And so when I go over to this side at -2, lo and behold, the height of the dot is at +4. And if you can see what's going on, -3, again, is -3 times -3. Negative times negative is positive. 3 times 3, 9. So as you can see, as you keep going to the left, the graph keeps going back up. And I'll put that, and notice, it's very important ideas, that we also see the numbers and the heights are identically the same going back up at the exact same distance. That's not perfectly drawn. So this is the basics of what a quadratic graph looks like. Now, one way to always draw this from any way you want, you're going to need to get familiar with how this is drawn. I'm just going to start from scratch again. I'm just going to slap up an axis here, black. And it's really important you pay attention to this. Oops, I should move that down. Let me just grab that and move that down a little bit here. Okay, back to my pen tool. Now, normally when you draw these things, it's important to understand the physical geometry of drawing the points. I like to start with 0. Okay, 0 squared is 0 up. I move over 1. Okay, kind of like that slope idea. I'm at 1 over. I square that. 1 squared is 1 up. Okay, now I go back to my beginning here at 0. I move over 2. I'm 2 units over, left and right, and therefore it goes 2 squared, which is about 4. Again, I can put the numbers, it's all about fitting the numbers to the graph idea, okay? You don't have to worry about super precise unless you're given a Cartesian plane. Now if I go to 3, I'm 3 units from this, I'll make really dramatic red spot here, this spot right here. I go back to that spot, I move 3 units to the right. 3 to the right gives me 3 squared up, which naturally 3 squared is about 9. Again, it's not perfectly to scale, but I can just say that's about 9. Now, there is the main idea of how do you draw the graph. 1 over, 1 up, 2 over, 4 up, 3 over, 9 up. Now that's 1/2 of the graph, which we're going to see is that we do the exact same thing. I don't even need to calculate. If I just move 1 over to the left, I know I have to go 1 up. I'll just use a different color, maybe this green's better. 1 up. If I move 2 over, and I'm just going to pick my own scale, 2 over in the negatives, I go 4 up. But I can also just look across to see where I should be, because that's the same height. I go 3 over to the left from this spot, this big red spot, 3 over, I should be 9 away from this red spot. And which, again, I'm already at that height, it's not perfect, but there it is. And the graph itself is what we call symmetrical. And you'll see that we can kind of call it a symmetrical U-shaped graph, but it's not precisely a U, and it's not a V either. That's an important idea for this. It's not a straight line. I'll put wrong ideas here. It's not a straight line set. Neither is it a straight up and down set. Okay. So to describe a U-shaped graph, this would be U-shape, but it's not precisely and exactly a U-shape because U implies it goes straight up together. It's not quite straight up, it's at a bit of an angle, but either it's not a straight line as we go and progress left and right. Okay, it's not going up at the same amounts. It doesn't have a slope, as it were. The slope keeps changing. And so there is a name that we call this properly. It is called a parabola. 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 Also known as a quadratic function. So this is the correct name. We didn't prove it. There's a way. That's actually a geometry shape, kind of like a circle versus oval versus triangle versus square. There is a shape called a parabola. This seems to model it. We didn't prove where it comes from. It's from lights in ancient Greek, how you cast a shadow. But we will assume at this point that's called a parabola, and it's very important that we can kind of see this in the fact that we can see that it's split. We can actually draw a split line, I'll do it in like green, where we can take the graph and see that this thing is precisely cut right in half on that red dot. Okay? That means it is symmetrical. Very important concept. Symmetrical. Mirror. Okay? It's a mirror, left to right. And it mirrors, and this is the key point, it mirrors from that starting spot there. Alright, this is the introductory lesson about what the graph is, and we're going to see in the next lesson about moving it.